So hello everyone, in this video we'll be solving another LeetCode problem and the problem name is Trionic Array Part 2. So you are given an integer array nums of length n, and a trionic subarray is a contiguous subarray from nums of L to R with L greater than equal to 0, R greater than L and n is greater than R, for which there exist indices L, P, Q and R such that nums of L to P is strictly increasing, nums of P to Q is strictly decreasing and nums of Q to R is strictly increasing again. Now we need to return the maximum sum of any trionic subarray in nums. So what the question is saying that you are given an array nums and you need to find a subarray, let's say this subarray, such that this holds the property of trionic array, which is this. It should be first increasing, then decreasing, then increasing again, and this subarray sum should be as max as possible. So this is what the question is saying, and we need to do this entire operation in O of n time. So in the part 1 of this particular problem, we have seen how we can get the trionic array property in O of n. So if you haven't watched that video, you can watch that out. I will pin that video in the top right corner. So still I will give you a little bit of glimpse how we can do this particular thing, or how we can check if a array is trionic or not, if it is trionic or not in O of n. So in that, what we were doing, we were keep on iterating the entire nums array, and we were keep tracking at what index this first increasing ends. So let's say that index was increasing 1, and then we were again keep on iterating to find the last index for this decreasing part. So we gave that index as dec, and then we were again checking for the last increasing part where that last increasing part index ends. So we were giving that name at inc2, and then in the end we were checking whether this increasing one part index actually exists or not. It is not equal to 0, right? And this dec and inc2 actually exist or not. This dec should not be equal to this inc1, and also inc2 should not be equal to this dec, and also this inc2 should be equal to n minus 1. So these were the things that we were checking, because if inc1 is 0, that means this actually doesn't exist. If dec is equal to inc1, that means that this part actually doesn't exist. And if inc2 is not equal to, if this inc2 is actually equal to dec, that means this part actually doesn't exist. And if this inc2 is not equal to n minus 1, so let's say what will happen, let's say this is not equal to n minus 1, that means there are further elements which will say that okay, this is the decreasing part, this might be the increasing part. So this breaks the property of trionic array. In that part we were trying to find for the entire array, not the subarray. So these were the things that we were checking, and this entire operation took O of n time because we are doing a linear iteration only. So this was the thing that we were doing. Now in this question, what we need to do, we are given this entire array nums, right? Now there might be many increasing, decreasing, increasing, decreasing, and lot of parts that we were happening. So this can be one possible subarray, this can be one possible subarray, and so on and so forth. There can be many subarrays that will follow the trionic array part. So first we need to take care about that, and also the second thing we need to take care about this sum part, that sum should be as max as possible. So how will we do this thing, both of the things in O of n time? So let's see now. So first of all, if you observe one thing, whenever we are going for the decreasing part, we know that there will be one increasing part before it, and there will be one increasing part after it. So there will be increasing part after it, and there will be increasing part before it. So can't we say that if we are starting our decrement from this particular index, we are starting our this decrement part, we are starting it from this particular index. So can't we say that we need to find the maximum sum of the increment that ends at this particular index I, right? So if we are searching for this decrement part, we need to find what is the best increment part that ends at this particular index I. So first we need to find best best here means maximum sum. So let me write it more clearly. So maximum sum increment part that ends at I. We need to find that. And if our decrement part ends at here, that means our new increment part will start from here, right? So can't we say that we need to find the best increment part that starts at this particular index j? So what I am saying, we need to find maximum sum increment part that starts at index j. So this is what we need to actually find. So what I am saying, let me write it more clearly. For if we are considering a decrement part, we need to get two things in O of one time. The first thing is that index I, that will denote the max sum of increment part ending at index I, at index I. That means increment part that is ending here I, and we need to find j, that will denote maximum sum of increment part starting at index j. So best increment part that starts from this index j, and it can go up till wherever it wants. So we can say that for this decrement part, we have actually find out the previous increment and the next increment easily, and we will keep on doing for this. So in the O of n iteration, what we will do? So O of n iteration, we will search only for this decrement part, and for the decrement part, what will be the previous increment part and the next increment part, we will do this in O of 1. We will do this thing in O of 1. And since we are only searching for the decrement part in the entire array, this will take us O of n time complexity, and for each and every decrement part, we are just checking its increment part before it and after it in O of 1. So the total time complexity remains same, that is O of n only. So what we will do, let me show you. So what we will do, we will pre-compute the maximum increment part that ends at index I and starts at index I. So we will pre-compute the maximum sum increment part that ends at index I, and starts at index j, because from I to j we will actually have the decrement part. If we have decrement part from I to j, so we have already computed the maximum increment sum that we can get till index I, and we can get the maximum increment sum that will start at index j. And there is also one problem. When we are taking the sum of the decrement part, we will consider this I twice, in the increment part and in the decrement sum also. We don't have anything with the j part, we don't have any problem with the j, but we will have the problem that this in the increment part, we will already consider the sum of ith index. So we will have the sum of ith index in the increment part, right? But when we are decrementing, when we are taking the sum of the decrement part, there also we will be taking the sum of this ith element. So we have counted this ith element twice. So we just need to subtract this nums of I from whatever the entire sum of the subarray that we can get. So this is the one thing that we need to take care of. So for the increment part, we will be computing the maximum sum of the subarray for the increment part and all that with the help of cadence algorithm. So I hope you know this algorithm. The maximum sum subarray algorithm it is, so you can watch that. It is not a tough algorithm, so we will use the cadence algorithm. So let me show you how we'll be solving this particular problem. So let me just show you the code now. So first of all, I am declaring an integer n. This is nothing but the size of the nums array. Then two vectors, increment and and increment start. This increment end is nothing but the maximum increment subarray sum that we can get who is ending at index I, and this increment start is nothing but the maximum increment sum that we can get for a subarray who is starting at index j. So this is what we are keeping track of. So first of all, I am declaring the answer that will be the final answer for the maximum sum subarray of the trionic subarray. So initially we are declaring it with as minimum value as possible so that we can keep track of the maximum value. So we are declaring it with -1e18, and then we are pre-computing the increment end part and increment start part with the help of this iteration. So we are just pre-computing it. So this is nothing but the cadence algorithm. This is also same cadence algorithm. So what we are doing, if this I exists and nums of I, so we are starting our iteration from 0 to n, so that we can keep track of at what index that is ending. We are considering each and every index as ending point here. So if nums of I is greater than nums of I minus 1, that means it is an increasing part. So just store the maximum possible sum that you can get till now. Whether this nums of I minus 1 plus nums of I is greater than the previous part plus the current sum or not. So among these, whatever is the maximum, just store it in the increment end part of this ith index, the normal cadence algorithm. Now here we are starting our iteration from back because we need to check what is the starting point from where we can get the maximum increment sum part. So in this we are checking that whether this I is lesser than n minus 1, and if nums of I is lesser than this nums of I plus 1, that means it is a kind of increasing character. So for this ith index we are saying okay, this is the starting index from where we can get the maximum sum part. So we are comparing among these both of them, whatever is the maximum sum, we will just store it in the increment start of that ith part. So nums of I plus nums of I plus 1, or increment start of I plus 1 plus nums of I. So again we are doing this with the help of cadence algorithm. So we have pre-computed the part for the increment sum for both parts, the previous part and the next part. Now we need to just take care of each and every subarray who's for the decrement part, and for that decrement part we can get the increment part in O of 1 time because we have already pre-computed that. So from index 1 we are just checking if we see a decrement kind of property or not. So from index 1 you can check whether this nums of I is greater than this nums of I minus 1 or not, and whether nums of I is greater than nums of I plus 1. So what it is saying, nums of I, let's say this is I minus 1 and this is I plus 1. So we are checking whether this part is increment, and from here nums of I plus 1, this is decrement. So yes, we find a decrement property from I up till wherever we can go, we will try to take the sum of the decrement part. So this is what we are doing. We are taking a variable j which is starting from I. We are taking the sum which will keep track of the sum of this decrement part. So now until our j is less than n minus 1, we need to check if this j is greater than j plus 1. That means j plus 1 is lesser, so obviously it is showing the decrement property. So until we get the decrement property, keep on taking the sum of nums of j and keep on going forward. Now a point where we say okay, now we do not have any decrement property here. From here the increment part start. So now we will check okay, if j is still less than 1, that means okay, we can get the increment part ahead also. So we are still checking whether the j plus 1 is greater than this current j or not. So this is the current j and this is, let's say, j plus 1. So yes, it is showing the increment property. So to find the increment property sum, we have already taken the decrement part sum, so decrement part sum will remain as it is. Now we need to take the previous increment part sum that will end at this particular index I, and we need to take the increment part sum that will start at this particular index j. So we will take increment part sum that will start at this particular index j, and we will take this sum of the increment part that will end at index I. And we have seen that in this increment part, index I will be counted twice, in this increment part and in this sum part. So we need to remove nums of I from the entire sum that we are taking from here. So just the simple expression you can say. sum of the increment part plus sum of the decrement part plus sum of the increment part again. Just remove nums of I from this sum, because it is counted in sum also and it is counted in increment end part also. So we were counting this twice, so we need to count it once only, so that's why we are decrementing this nums of I again. So whatever is the current maximum, and if this sum is greater than this current maximum, so you need to update this answer with the current sum that we have. And this will keep on going for each and every decrement part. So you can see it will keep on going for each and every decrement part, and whatever is the maximum sum trionic part, you can say this part, maximum trionic subarray sum, that will be returning in the end. So I hope you understand this problem. If you still have any doubt, you can write in the comment section. I'll be there to answer as soon as possible. So if you have any doubts, you can write in the comment section. But I hope you understand this solution. I have tried my best to explain this solution in as simple terms as possible. So yeah, I hope you understand this solution. Still, if you have any doubts, you can just write it in the comment section. So yeah, thank you for watching.